Inside the curing press, raw rubber transforms at 180 degrees Celsius, 356 degrees Fahrenheit, under 25 bar. If a 2 millimeter bubble escapes detection for just 50 milliseconds, a tire can rupture at 200 kilometers per hour. Here's how nearly 200 materials become a structure that survives years on the road. A single plant builds up to 15,000 tires per day, and 60% of highway failures trace back to defects formed in seconds. Heat, pressure, and tension must hold inside narrow windows. Today we go through the full process: compounding, belt and ply assembly, building, curing, inspection. Miss one tolerance, and the tire fails before 5,000 kilometers. Before any layer stacks, the rubber compound must hit exact viscosity, or the entire structure fails downstream. Internal mixers blend elastomers, silica, and carbon black at 110 to 150 degrees Celsius. Torque and temperature sensors sample every second. Mooney viscosity must stay within plus or minus 5 units. If viscosity drifts, polymer chains misalign, doubling tread wear within 20,000 kilometers. Sheets cool and pass through mills that align polymer chains. Laser scanners hold sheet thickness to plus or minus 0.1 millimeter. Even now, long before curing, wet grip and tread life have already been set. Perfect rubber isn't enough. The belts must align within fractions of a millimeter. Steel cords receive a brass layer to bond during curing. Cutters slice each ply at approximately 18 degrees. Laser sensors track width, angle, and splice offset. If belt alignment drifts plus or minus 0.3 millimeters, radial runout exceeds 1.5 millimeters. The tire fails balance tests. If splice offset is off by just 0.2 millimeters, ply curling begins, invisible until high-speed rotation. Precision here is the foundation of uniformity. The drum builds the tire, but tension decides whether it survives load and heat. Layers stack outward: inner liner, body plies, steel belts, tread. Body plies tension to approximately 15 newtons per centimeter. If tension varies by more than plus or minus 2 newtons per centimeter, heat flow shifts during curing. Delamination starts within 5,000 kilometers. Drum speed sinks within plus or minus 0.5%. A small drift changes fiber angles and destabilizes the footprint. The green tire now has shape, but zero strength. The next 12 minutes decide everything. This is the irreversible stage. Every upstream error becomes permanent. The green tire enters the press. A bladder inflates with steam to 20 to 25 bar. Heat rises to 170 to 180 degrees Celsius, 338 to 356 degrees Fahrenheit. Sulfur crosslinks bond every layer into one structure. Thermocouples monitor multiple zones. If temperature drifts plus or minus 5 degrees Celsius, just plus or minus 9 degrees Fahrenheit, internal bonds weaken and load capacity can drop 30%. The first 90 seconds lock roughly 80% of final strength. Inside the mold, steam forces rubber into every groove. Heat is a tool and a risk. Most people think the tire is finished after curing, but the invisible control loop is still working. Thermocouples sample temperature 10 times per second. If a cold spot appears, valves correct within 200 milliseconds. Pressure sensors detect asymmetry within plus or minus 0.5 bar and shift mold halves by micrometers. Bladder expansion is tracked at 100 Hz and corrected 20 times per second. Process identity, Closed-loop thermal symmetry, temperature, pressure, and bladder load stay inside a synchronized plus or minus 0.5 bar differential, from drum tension to curing pressure. These corrections fire long before an operator sees an alarm. Every tire passes 3 tests: X-ray checks for voids, misaligned belts, and splice defects in under 3 seconds. Uniformity testing spins the tire under load. Radial force variation must stay below approximately 10 newtons. Leak testing pressurizes the cavity to detect microscopic sealing issues. A 1 millimeter void can rupture at 180 kilometers per hour under 2.5 bar internal pressure. From a 50 Celsius compound sheet to a 180 Celsius, 356 degrees Fahrenheit cured structure, everything happens inside a 12-minute thermal pressure window. A 12-minute cure controls a structure expected to survive more than 100,000 kilometers. If you want the high-speed version, motorcycle tires, aircraft tires, or racing slicks, tell me which line we should break down next.